Today we're on page 6 of our Chapter 14 notes packet, the ambiguous case. We're going to continue our practice applying the law of signs, but in a different setting. And we're going to be asked how many triangles can be constructed given a certain set of information. And this is also known as the ambiguous case. The word ambiguous means open to more than one interpretation, or unclear, or not exact. When two sides and a non-included angle of a triangle, otherwise side-side angle, are given, the triangle may not be uniquely determined. For this reason, side-side angle is called the ambiguous case. With side-side angle information, 0, 1, 0, 1, or 2 triangles may be formed. Given two sides, A and B, and an angle A, the possibilities are, well, it may be such that the length of that second side, in this case side A, is not long enough to even form a triangle. So there's 0 triangles here that can be constructed. Or the length of that second side A may be just such that 1 triangle may be constructed. Or the length of that second side A may be such that you have 1 triangle that's constructed here, or you might have another triangle that can be constructed based on the length of that second side. So under these conditions, we're going to determine, using law of signs, how many triangles can be constructed. Is it 0, 1, or 2? Can never be more than 2. So given side-side information, you can use the law of signs to solve a triangle. To find the number of triangles that can be constructed with the given measures, we're going to use the law of signs to find the second angle's measure, determine this angle's supplement, and then check the triangle's angle sum. So we're answering a question. Given the following information about triangle ABC, tell how many triangles can possibly be constructed. Okay, so we have number 1, angle A is 35 degrees. Now, it's not necessary to draw the triangle, but I think it's easier and more clearly to see the sides and the angles opposite those sides. All right, so angle A is 35 degrees. Lowercase a is 9. Lowercase b is 12. So the side opposite angle B is 12. So we're going to find angle B first. All right, so we're going to use law of signs to find a second angle's measure. Now we're going to draw two tables. We have our first triangle, and we have our angles A, B, and C, and our second triangle. Angles A, B, and C. So we're going to fill in the angle measures. Angle A is 35 degrees. That was given to us. That is going to remain for the first and second triangle. Whatever our given angle is, that belongs to both triangles. Next, we're going to use law of signs to determine the second angle's measure. And we know the length of the side opposite angle B, so we're going to find the measure of angle B using law of signs. So 12 over sine of angle B is equal to 9 over sine 35. Cross multiply, we have 9 times sine of angle B is equal to 12 times sine 35. divide by 9. The sine of B is equal to 12 sine 35 divided by 9. Now we're finding angle measure, so B is going to equal the sine inverse of our fraction 12 sine 35 divided by 9. So we go to the calculator, make sure you're in degree mode. Second sine fraction 12 sine 35 divided by 9. We'll round this to the nearest degree. All right, so that's 50 degrees. So angle B equals 50 degrees. Okay, so we put 50 degrees for angle B in our first triangle, and in our second triangle we want the supplement of 50. All right, determine this angle's supplement. So 180 minus 50 is 130. Now check our total. All right, the total of 3 angles of any triangle would have to add to 180. Right? So the angles would have to add up to 180. All right, so we take 35 plus 50 brings us to 85. So that means angle C would have to be 180 minus 85, 95. All right, so these angles form a triangle. So we have our first triangle. Now, for our second triangle, we have angle measures. Angle A is 35, angle B is 130. The 3 angles have to add up to 180. If they're over 180, it doesn't form a triangle. Well, 35 and 130 is 165. So that means that angle C would be 180 minus 65, which is 15 degrees. All right, so these form a triangle. So we have 2 possible triangles here. So how many possible triangles can be constructed? 2 triangles for this particular problem. Number 2, angle A is 82 degrees, BC is 12, and AC is 11. Let's draw a triangle. Angle A is 82 degrees. BC, that's the side opposite angle A, is 12. AC, the side opposite angle B, is 11. How many triangles can we construct? Here we'll set up our 2 tables. Our first triangle, our angles are A, B, and C. Our second triangle, angles A, B, C. Now, using law of sines, 11 over sine of angle B is equal to 12 over sine 82. Cross multiply, 12 times sine B equals 11 times sine 82. Divide by 12. Sine of B equals 11 sine 82 divided by 12. So angle B is equal to the sine inverse of that fraction. 11 sine 82 divided by 12. Second sine of our fraction, 11 sine 82 divided by 12. We get 65 degrees. So this is equal to 65 degrees, approximately 65 degrees. Oh, I forgot to list angle A. Angle A was 82 degrees. So the angle A is 82 degrees. Angle B is 65 degrees. Take its supplement for the second triangle, 180 minus 65. is 115. All right, for our first triangle, remember the three angles would have to add up to 180 degrees. 82 plus 65 is 147, so that means angle C, that's not over 180, so angle C would be the 180 minus 147. That's 33 degrees. So angle C is 33 degrees, and these three angles would form a triangle. But here, if we take just the two that we have, the 82 and 115, okay, just summing these two up, this is over 180 degrees. Okay, so there's no triangle here. There's no second triangle. It doesn't work. There's only one triangle. So how many triangles can be constructed? One triangle. Continuing on the next page, number 3, we have angle B is 79 degrees. Let's draw a triangle, ABC. Angle B is 79 degrees. AC, the side opposite angle B, is 10. AB, the side opposite angle C, is 15. And we need to determine how many triangles can be formed given these particular side-side angle measurements. First triangle, second triangle. Our angles are A, B, and C again. Okay, let's substitute into the law of sines. We're finding the measure of angle C. So 15 over sine of C is equal to 10 over sine 79. Cross multiply 10 sine C is equal to 15 times sine 79. Divide by 10. Sine of C equals 15 sine 79 divided by 10. We want the angle measure, so angle C is equal to the sine inverse of this fraction. 15 sine 79 divided by 10. Let's go to the calculator. Second sine of our fraction, 15 sine 79 divided by 10. We get an error. Okay, so there's no triangles. Well, why did we get an error? What is this value here? What's the value of this fraction alone? So if I take away the sine inverse, that fraction is equivalent to 1.472 something. So that's over 1. All right, and we know that there are no angles that have a sine value greater than 1. That's why we came up with an error. So it's just not possible to construct any triangles given an angle of 79 degrees and side lengths of 10 and 15. So this is 0 triangles. No triangles. And number 4, angle C is 109 degrees. And lowercase b is 20. And C is 19. Now, some of you might say, well, this isn't possible. This 109-degree angle would have to be the largest angle of the triangle. And so opposite that would need to be the longest side. So it's simply not possible. You could see that right off at the beginning and say, well, you don't need to do any work. There's no triangles, okay, that would fit this. But suppose you did not see that, you didn't notice that, we would go with our two charts, first triangle, second triangle. Our angles are A, B, C. The measure of angle C is 109 degrees. Put that for both triangles. And now, using law of sines, we'll figure out angle B. So 20 over sine B is equal to 19 over sine 109. Cross multiply, 19 sine B equals 20 times sine 109. Divide by 19, sine of B is equal to 20 sine 109 divided by 19. So angle B is equal to the sine inverse of the fraction, 20 sine 109 divided by 19. Second sine fraction, 20 sine 109 divided by 19 yields approximately 84 degrees. So B is equal to 84 degrees. Okay, so for angle B here, 84 degrees in our first triangle. The angles would sum up to 180, but again, all three angles would add up to 180. Adding just these two, we're over 180. So this isn't possible. And if we take the supplement of 84 for our second triangle's angle B value, 180 minus 84 is 96. Again, if we just take the two angles, 109 and 96, right, this is over 180 degrees. So these can't possibly form a triangle. So there are no triangles under these set of conditions. And this concludes our lesson for today. Thank you.